Very good. Let's kick this off. My name is Dave Martin. I'm K5YFO. I'll be joined by my cohort in crime, Richard Hensley, VK2ARH or W5ARH. We'll tell you, I'll introduce him a little bit more. What we're going to talk about today is something that the Cowtown Amateur Radio Club was sort of experimenting with. We looked at what's next. We got tech. How many techs we have in here? There's tech. Most of the people that we get in our testing program at the club end up with their tech license. We give them 6 months membership in our club when they pass the test. But congratulations, you passed your test. You bought your Baofeng. Now what? You know, and they go away. So what's the hook? How can we get to these people and say, look, here's a lot more about ham radio than just your Baofeng? So we're looking at, our first effort was to build these tape measure antennas for 2 meter. And at the bottom here is an attenuator, and you can put that with your handheld radio and find a hidden transmitter. And you can have variations of that, the time it takes, who's the shortest time, you know, or this, that, and the other. The valid reason for that is the club a number of years ago did a balloon launch. And the balloon goes up and bursts, and the payload drops, and you got to find the payload. And so you end up using the fox hunt method to find your payload. So there's some practical things to it, but we built the antennas, we went out and used them, and you can see one of our hunts, we had a pretty good turnout. And so it was obvious that we had a number of things that the club members were interested in doing. So we have a breakfast every Saturday, and we ended up, a bunch of us forming a little ad hoc committee. Here's our committee. Most of my cohorts in crime are in the room today. If I can get my thing to work. Myself, Mike Barnett in the back, Mark Colross is over there, and Richard. So these are the project team that were barnstorming circuits and projects to figure out what to do. Well, here's what we came up with. We wanted to build projects that you could do on a weekend with mentors at our club station that you could find useful. You're not something you just build and set on the shelf and not ever use it. Learn something from it, and above all, let's have some fun. You know, and enjoy the hobby. So here's the list of things we came up with. You got to find your tools. If you've never started, then you know you got to get at least a screwdriver, a pair of pliers, a multimeter, and you know you can go on and on and on. But hey,
could you go to the previous slide just 1 second?
Yep. What do you want on that one?
Yeah, that's it. Thank you. All right.
Okay.
See, I missed the original meeting that introduced me.
Okay. Well,
we can send a copy.
We're going to have this. We're recording it, and we'll certainly have it on the slides that we'll make available. The easiest thing is just get on Amazon. You can get it tomorrow. You guys got everything that they think that you'll need: soldering iron, multimeter, snips, screwdrivers, solder sucker, solder, tweezers. All in a nice little package. So if you're starting out, that's an simple and easy way to do that. And so that gets checked off the list quite easily. Then we're going to go.
Can I ask you a question?
Yes, sir.
Okay, back to your tools.
Okay.
Of course, you can see anything you want to on the internet. And I see that soldering gun that's a little sponge.
Yes.
And then I see something on the internet about this ball of copper
Yes.
thing to tip.
Yep.
And the sponge will cool the tip, and does it make a difference?
No.
Okay. Because I was telling a friend of mine, I have welded since I soldered, and I haven't welded for 50 years. So I'm learning all this again.
Fords and Chevys, what's your preference?
Okay.
Okay? They'll both, what you want to make sure is the tip will oxidize.
Yeah.
So you just something to clear that off. You're not holding it on the sponge, but I've used both. I use the sponge and the little copper ball. What you want is just to get a quick, clean tip. And this one has also a number of tips that come with the
soldering station
right here, it's soldering.
Station I got for Christmas.
Okay,
It's also got a heat gun.
Yeah, perfect. Yes, sir.
Okay, to his question, for hobbyists, the sponge is fine. If you're in a production environment where you're soldering over and over, the sponge will slow you down and the copper can work good.
But we're not in,
Yes.
we're not, understand, but, we're looking at projects for the home and we're not, we're hopefully not building that.
Explain it, thank you.
Not building that fast, but yeah. So, what we're seeing is the number of 30-year-olds come through the club that live in an apartment and haven't got anything. When I first went off to my first work assignment with the Army, all my stuff was at home, and so I ended up having to start from scratch, those deals. So that's kind of where a lot of people are at. Start from scratch. Have something that you can work with. So our first project is an in-fed half-wave antenna. Well, here's an MFJ, $90. Boo. Let's build it. So we're going to look at this gentleman, Richard Hensley. Richard is a true Southerner, we like to say.
You're gonna have to read all that stuff. It's on the right side to us.
Yeah,
I can't see that.
That didn't turn out very well on my slide. So let me just introduce Richard. Richard came to us via COVID. He works for an international company that flies him all around the world. And he was in Fort Worth when his home country says, "We don't want you, stay out." So he looked around, he had a corporate apartment over here off of 7th Street area. He looked around and found our clubhouse, and then he came over to test, he's also known as W5ARH, and we got a new club member out of that. And we've enjoyed having him with us for the last year and a half, 2 years now. So he's become a very integral part of our club. And so I'll let Richard take over the next couple of slides and introduce our first project is this in-fed half-wave antenna.
Thanks, Dave. We're actually recording this, so that's why we need to switch this microphone.
And there'll be captions for those who don't understand the language.
And if I can manage switching the microphone, you can build an in-fed halfway. So look, let's introduce it. Thank you for the introduction. I'm pleased to tell you that I can get back to Australia now that's opened up. I can move backwards and forwards.
Why would you want to, you're Texas?
Well, I got to tell you that, but I do have, which is biggest, New South Wales in Australia or Texas?
Attitude-wise?
Sorry?
Who cares?
Yeah?
We got Whataburger.
Okay, you got Whataburger, all right.
Less deadly animals.
I'll give you the answer to that at the end of the presentation. So, in terms of looking at the program, as Dave indicated, the first session off the ranks is to build an end-fed half-wave antenna. So we're splitting this over 2, possibly 3 actual events. The first is on Thursday, February 18th, where we'll just have a presentation night in the clubhouse. For those that have not been there, this is our clubhouse. Quite a nice little den, if you will, to be able to do these kind of things. We'll cover a bit of the theory, the overview of the antenna, a fair bit of the safety considerations, because you do need to be aware of those when you're using an end-fed half-wave. Talk about how to deploy it, but more importantly, we'll teach you how to build it, we'll show you how it's built, and we'll also have some kit available for people to be able to do that. The following Saturday, if those who wish to come along, we will actually build them. So we'll have people there who are experienced at building, we'll talk you through, help you through it, and the idea at the end of that Saturday session, you'll be able to walk away with an unun, if you will, that's been tested and is ready for use. So they're super keen. It is winter probably at this time of year, but shortly thereafter we'll have an erecting and tuning session, so we'll actually go out perhaps for one of the parts, get the antenna up into a tree, we'll teach you how to tune it, perhaps maybe do a potor activation, and certainly have a QSO with somebody else as we work our way through. So when you look at it, why did we choose the end-fed half-wave antenna as the project? And bottom line is, if we go back to the project principles that we're trying to do with each of the sessions that we have in the Buildathon program, we're trying to find an option which is relatively inexpensive. It's easy to build, but it also delivers a learning experience for the new hands or someone who's new to construction techniques, if you will. We'll go through soldering, teach you how to wind toroids. We'll have some discussion today and also during the session on the Thursday about selecting the various components. Construction techniques, we'll teach you how to tune antennas. I'll also cover a little bit of education theory and practice, if you will, about how to practically use that. The idea, again, with each of these projects is to deliver a practical piece of kit that you can then subsequently use in your amateur activities. But more importantly, it's a great deal of fun and enjoy that process and that journey. Now, why did we choose the end-fed half-wave? I have to say that it is probably one of my most favourite antennas because it is so easily deployed. It is multi-band, and this is one that Dave built sitting up here, and you can see the resonance on each of the 40, 20, 15 and 10 metres on the way through, and it is a very capable antenna. It's not going to outperform a beam or something like that, but in terms of flexibility and use, it really is a truly capable antenna. And you can deploy it both as a portable type situation here. I wouldn't say this is permanent, but in fact, that box there, which is one that we built, that was used on field day last year out in Trinity Park, and with great deal of success. And here are some of the options that we're going to show you and look to work as we build our way forward. Now, when I say that it's a very effective antenna, I'm not just pulling your leg on that. Sorry, do you use that expression here in Texas? just need to check. So look, this is a end-fed half-wave. Sitting that's on my front yard back in Sydney. You can see the wire running up through there. Using only 5 watts, this was the traces I was getting. You can see all across the Pacific there one evening on 40 metres. And by the way, it was probably about 4.5 watts, and it was running through a 50-foot piece of coax. So by the time I'd worked through the efficiency on the unun, we were probably getting about 3.5 watts probably radiated power. Very successfully there, and you can see on 40 metres doing quite well. Now I hear a little voice, somebody saying, yeah, but it was, the band was going to be wide open and you're going to get there every now and then. Well, it wasn't. I mean, if you look here, you can see that on that particular day on 40 metres, it was only fair at night, and you see the shadows cross here, so it was only fair band conditions, very successfully running on FT8 there. Also, if we look at the next one, this is on 20 metres, another day. You can see it's daylight here now, and I'm successfully working all the way into Europe, all the way across the United States. And when I took this screenshot, I just finished working some guy over in toward New York way there. If you can see there, and if you can look down that particular list, there's quite an array of countries. Canary Islands, actually worked long past all the way around to the Canary Islands. Belize, Slovenia, Italy, the United States, England, and what have you. That's with an end-fed half-wave, and in fact, at that particular point in time, I was using this fella here. So that's, and we'll talk about the different types of kit options that we're going to make available to people on the way through. 5 watts using a QDX, if you will, here, and there's a close-up of wasn't using the antenna tuner to tune the antenna, but simply to record the power out that was going through it and to keep monitoring it. You can see it just under 5 watts there. So the end-fed half-wave is a very practical antenna that can produce some really good results. when you look at the options that exist, there's two ways you can go about building it. You either build one for field operations, something you can toss up into a tree. Got to pull these out before I do, but I'll just keep talking as I do. Something you can quickly toss up into a tree if you wish to do so. Yeah. So this actually went back in my suitcase when I went home, and lo and behold, there's an end fed halfway with all its antenna. It's Ballon. It's Unun. So you can see how portable that is. That's the whole antenna, right? And show people afterwards with a little piece of code. You don't need to have anything too fancy to be able to do it. That one, which is this one here, was one that I used again with the same effect, the same success on the way through. So a variety of options. You can buy kits on the internet. Unless you're buying this one from the QRP guys, the ones from China generally tend to come with inferior toroids. So I wouldn't recommend that you do that. But as you can see, the advantage of these type of antennas is you can use, or these type of builds, you can actually use the structure that you build it around to wrap your wire antenna, wrap the rope, toss it in your bag. When you go out, unfurl it, throw it up into a tree, and you're in action. The same principles, however, when you go to build that, can also be used for a more permanent installation. So here, that is actually the inside of this little black box here. That's the one that was using on the field day here. And I can't remember, I think we got about 180 contacts, something like that, over field day, which was a lot of fun. But the same technique for building the portable ones in these kind of guys is exactly the same for the permanent installations. You just need to mount it into a case. So you've got to drill the case, put the other bits and pieces around it, but it works terribly well. So the options that we look for when building for the Buildathon, we needed to build something that was practical and easy to do. We wanted something that was going to be very cost effective and inexpensive to build, be able to perform well, and of course have a wide degree of usability for it. And by the way, I invite you to come and have a look at these. This little baby one here is my favourite. I'll point this one out. It's the most efficient of all the lot, but it is limited to 20 watts on SSB, and you wouldn't want to run more than about 10 watts continuous on digital on that one, but that's a very efficient little antenna. When you go to build them, and we've done a fair bit of research on this, all toroids are not created equally. You don't just grab a toroid of the right size and wind it and expect the same sort of results. There's a massive difference in efficiency between each of the various toroids. So what we've done is we've selected toroid options, if you will, for the project that are going to deliver a high level of efficiency. So we're talking, at least we want something in the mid to high 80s, and if better, certainly into the 90s. This little fella here is about 90 to 93% efficient, and this one here is about 2 percentage points behind it. So very efficient, if you will, in terms of what it is that they're doing. When we look at the toroids, you can see here we've got a range that are available. They are a bit more expensive than this if you're buying them one-off. If we have enough people who are wanting to participate in the project, we'll obviously make a bulk buy and get 25 of them. But as I was showing down through here, this little tiny fella here, he's 90 to 93% efficient. The fat boy, as I call it, which is the big chunky guy here, that's high. Whoops, don't know what happened there. That's in the high 80s. Let's just try and refresh that. Have to bear with that as we go forward. That's in the high 80s, and for higher power, because you have to balance between the size and the power rating of the device. This one also gets up into the mid to high 90s, depending how much you stack them, because you can stack toroids as well as having the individual ones.
So, Richard, the power that's not in the 90 to 93%, what happens to the 7%?
Heat. Yeah. So if you have an inefficient wind, if you will, on the toroid, the power that's not getting radiated works itself in terms of heat in around the toroid. And if you heat the toroid up too much, it'll lose the job that it's doing, if you will. You'll destroy the process. I'm trying to think of the magic word, but basically it will stop working and you'll melt the thing down. So there's no point getting a small tiny one that's destined for QRP and running 250 watts through it, because you'll basically destroy it. My technicians have fixed it, Dave. It looks like that it just come loose a little.
What website are you looking at?
For these here?
Yes, sir.
on another presentation, I have the reference. I can get it for you. But I'm sorry, I didn't put it up. I did this on the aircraft coming back from Salt Lake City on Thursday, so I didn't grab
What's the
it.
gain on that antenna?
I'm sorry?
The gain?
It's about, you stumped me there, it's about the same as a dipole. So when we do the theory session, we'll be covering radiation patterns, methods of deployment, whether you put an inverted L as a straight, where the radiation pattern is relative to the antenna itself. But if you think of a dipole, it's about the same as that. Okay? There is a degree of directionality with the radiation patterns, and it tends to be along the line that the antenna is actually deployed. One of the great things about using digital and being spotted is you can actually see the strength of where your signal is actually landing, and we can go through much of that. As I said, they're the various options that we have available, or we will be making available in the project. Some are easier to wind than others. I mean, it's you need to be fairly dexterous to be able to wind this little fella, and you need to be even more. This one is actually difficult to wind because it's such a big thing to wind it around. The easiest ones to wind were these two guys, but they're not the most efficient. So it depends which way you want to run and do that. So the last slide that I have here, just introducing the project. So what we intend to do is to make a kit available that you can see here. It'll have all the components necessary to be able to make the end-fed half-wave. So we'll do the winder, a couple of choices available. There's two sizes of this and two types of these small ones. The toroid, depending upon which one we ultimately select. Magnet weld we supplied, a high voltage capacitor, zip ties to lock it all in, the BNC connector, and an insulator to be able to put at the other end of your wire, and the hardware to be able to do it. There'll be some instructions, but more importantly, there'll be people standing by to actually help you make the thing, show you the techniques, and work its way through. We do expect that people will provide their own antenna wire, a halyard, and the coax. People have got their own cable, they've got their own wire, whatever it is that they want to use. We expect it'll cost somewhere between about $15 and $20 for everything, depending upon the choice that you make. And if we do make it, a couple of dollars on it, the process was to go to the club. Bottom line is, we'd love to have you along. Come and join in the fun. It's going to be a great program this year. So, Dave, thank you.
Thank you, Richard. Leave it there, right?
Yes, you need to rewire.
Grab the magic box. Get it somewhere? There, thank you. Okay, get that back. As Richard said, I built one of these just to do my own proof of concept. And this is I put it through my little tester, and after one adjustment, about 6 to 12 inches, I got these perfect, almost perfect spots on 7, 14, 21, and 10 meters. So the proof of concept works. I use that on a pole up in like an inverted V in my backyard. If you use really thin wire, those of you in apartments might be able to hide that wire for a while and avoid the Nazi HOAs or management or whatever, so you can get a real stealthy antenna.
Dave, can I just jump
Yeah.
in there? For those that are new, don't be put off by having to have a massive backyard to be able to do it. I, when I'm here in the US, have to live in an apartment. I've actually worked all states from my apartment with a whip antenna.
Yeah, it can be done, and and a lot of people are in that situation where they're in an apartment and that they don't have a yard. It's even put up simple antennas, much less a 3-beam step IR antenna of thousands of dollars. You can still have fun with this hobby, and that's what we want to prove. The next thing we wanted to look at was introducing some computer-aided tools. This is a VFO RF generator, built with an Arduino and one little chip that generates frequencies and a readout. And this is handy as sort of a base tool, first of all, to enjoy what we call the joy of oscillation. It works, you can see it, you can hear it, and then we can put it with another device. This is a direct conversion receiver that with 2 chips, an audio output up here, and a chip that takes the output from the generator and feeds it into a mixer chip, and you have a radio that you can receive sideband and CW and digital signals on. And you can see the readout's about 1 inch big, but still readable enough. The other thing is if we add another little board with an LED, we can use the same generator to sweep your antenna. When the LED goes out, you have a resonant frequency read on the little readout. So you can see, instead of having a fancy thing like an analyzer like I was using, you can figure out by twirling the dial and figure out where the LED goes out and see where the resonant spots are on your antenna after you've made the right adjustments. Then the piece de resistance that we're working on. Remember, we're targeting this for technicians. If you look at your spectrum chart and a frequency allocation, techs have data privileges on 10 meters. So you've got that capability. You can do CW, Morse down in the lower ones, but you do have data on 10 meters. So we're looking at a transceiver that will do FT8 on 10 meters. With that readout right there. We're doing the engineering prototype right now. We've got several of us that are building chip. So that's our hope. We're going to try and work the bugs out of that. We've got some good software expertise in our club. So we will capitalize on that, various talents to make this project work. These are prototypes in progress. One of the learning curves, at least for some of us, like me, is to use KiCad pre-C circuit board design. So instead of this wired mess that I built with wires going everywhere, we might design some printed circuit boards that you're pushing through-hole parts through and be able to solder and whatnot. So there'll be a learning curve for some of us too as we get through there. We're not going to do surface mount or any of that. We're going to try to stay with through-hole parts as much as we can, except for some of those chips that get really fine number of pins. Well, we're going to use holders for those and solder them on and then plug those into sockets. So we're going to make this available. We'll have our build materials lists for each of these projects. We'll make it available to other clubs. We'll have all of this posted. Here's our contact information that we have on there. Questions?
Do you mind going back to that contact page?
Yes, sir. This is the top one is our groups IO. We're also, look for us on Facebook. And our major entry is at cowtown.org. Do you think of any others, Mark? Does that pretty much cover what we need?
And they're all linked to from your website. So
Yes.
you remember one thing.
Yes.
And one,
I think the program has our website on it. I think.
Yeah, the educational pamphlet does.
Yeah. And we have a YouTube channel, so this will be on the YouTube channel.
So we'll be willing to share this. This is nothing proprietary or any way our own. In true amateur fashion, we steal from everybody.
And share with them.
And we, yes, sir.
On your hunt that you were making, is it gonna be a 9-to-1, 49-to-1, what?
I think we're doing 49 to 1.
49 to 1.
I noticed you had the capacitor and tune the
Yes.
length of the wire, so that's what I figured.
Yeah, the diagram is 7 turns one direction, crossover, 7 turns the other, with a 150 puff capacitor across that. And that seems to flatten out the Biswar, especially on the bands, the frequencies of interest that we have.
I haven't tried one of those, I don't know. What's the length of the wire?
66 feet plus or minus.
Okay.
And it's a half wave, so 66 feet, but you may, depending on surroundings and, you know, size of wire, you're gonna make some adjustments to optimize it, and that's why it helps to have some sort of a way to look at where it's at, an analyzer. But
I will cover options for putting a coil in there to shorten the length of the
Yeah.
antenna.
yeah,
And also you don't have to use it for 40 meters, so I'm about to go and construct one in my apartment this weekend to do 20, 15 and 10. And just forgo 40 meters, we're just going to halve the length, so it's going to be down around 33 feet.
if you look for in-fed half-wave antenna on the internet, you'll drown. You'll drown in all the references that are there. And so what Richard has done is distilled so much of that down to what we know will work. And he's got examples up here of things that will work.
They've all been tested.
They've been tested. Being modest, he ran our digital, he and one other station ran digital for field day. And they were a third of our contacts. The Charlie Whiskey guys were another third. And so I think if you look at the clubs that ran both CW and data, you'll see that the data always contributes a significant amount of contacts to the overall score, without a lot of work, quite frankly.
A lot of skill though, a lot of skill.
Yeah, that's tough reaching up. Oh, answer that guy. Oh, well, answer that guy too. Oh, he answered my CQ. Let's get him. So it's really what's surprising to me is you've seen Richard's maps, and we've tried to run that grid tracker program so that as people come up to visit us at field day, we have not only all this numerical stuff running on PC screen, but we have a graphic of what's going on and you can see it. Because part of the digital mode is that if you're logged into several of these, you're listening and you're part of the reporting network when you're doing those. And so you get an idea of where your signal is going. And you can, I've used some digital modes to actually build an antenna and see, how does it perform? What direction does it do? Who's hearing me? Am I going north, or am I just going to the two coasts? So a lot of interesting things that are going on in both the analog part of ham radio as well as the digital part. So we're going to try and bridge that, and hopefully we'll strike some interest and we'll grow our club accordingly. Any other questions, comments, rocks, whatever?
We're
Well,
kind of
thank
talking
you.
about if there's a club that wants to do this, but they don't have there's a lot of clubs that just don't have enough people to do things. And there are people in a club that want to do this, but they don't have the mentor to be able to help them. We can somehow supply that, either via Zoom or depending on where it is, maybe in person, be that mentor also. So if you do own clubs, try to do stuff, try to, get people involved in doing things, just let us know and try to work something out.
This will be posted up there. You can see what toroids to buy, because Richard's done the analysis. What works. We're available, Zoom or otherwise, to assist and support the interest in the hobby. Well, thank you very much for attending today. It's been a pleasure.